Alright, so today we're going to be going over the proper installation and procedure to install the timing reference sensor or transducer into a C13 engine, as well as going through the actual procedures in CAT. So right now I'm just putting in the serial number for the engine that we're going to be working on, and then going into the documentation, and then from there to the C13 industrial engine up at the very top right there. Next, we're going to be going down to the troubleshooting tab, second from the last. And then from there, we're going to click on that first link in the C11, C13 engines. You're going to see the big list of results on the right. We're going to want to go all the way down to the very, very last option, which is going to be your timing calibration procedures. And once we get inside of that, we're going to see these these possible fault codes that you could see, any reasons why you might be calibrating the timing on this engine. From this, at the very beginning, you're going to see we're going to need the transducers, adapters, this cable and the harness thing. This is what you're going to need. This is just the outer case for the timing reference sensor. There's also going to be a datacom in there. This is your actual transducer. This is the box that it comes in. It's wrapped up in this like yellow paper and has a very specific plug on the end of it. And as you can see, there's that bolt with the O-ring on the very end of that. That slides up and down the entirety of that transducer itself. And that is very important for spacing the transducer so that it doesn't rub up against the crankshaft and break off. Continuing down through sys, we see and go through some more idler gear and timing mark stuff. With what we did was we used the valves to find TDC. This is when Dan and I started to get the valve covers off, as well as the gasket, to get out the rocker levers, so we could determine what top dead center was using valve overlap and all that good jazz. What we're looking for is for both of the rockers on cylinder 1 to be loose and both the rockers on cylinder 6 to be tight. Alright, here you can see Dan starting to turn over the engine by hand using the barring tool. The barring tool is just a simple little idler gear that you can throw on the end of a big ratchet, and it'll mesh up with the gears on on your flywheel, so you can get the engine turned over without having to use a starter or anything like that. That way you can get it precisely where you want it. Now we're just feeling out the valves to make sure that we're in the right spot where we want. Except we are gonna run through it just a few more times to make sure that everything is working properly, and we are in fact on cylinder 1 TDC. Here, I'm watching the front of the engine to make sure that we are going in normal rotation. Normal rotation is going to be clockwise when you're looking at the front of the engine, and counterclockwise when you're looking at it from the flywheel. While we're getting the engine turned over, I'm going to go over why anyone would be wanting to recalibrate the engine timing. Two of the biggest reasons would be codes 637-11 and 637-13, which were the two codes that were at the very top of the sys page. 637-11 indicates that engine timing is offset, meaning one or more cylinders aren't firing when they should be. 637-13 indicates a calibration is required, which is just indicating that something needs to happen for the engine to run properly. Right. So when we're looking at installing the timing transducer, we're going to be installing it on the left side of the engine inside of a little hole that you're going to see right now. Inside that hole, you're going to be able to see the crankshaft counter throw, which is that shiny surface that you can see right now. We're currently going up to the gap that the transducer is reading that you can see the edge of right there. That is the gap that the transducer sees that indicates TDC. And when you're installing the actual probe itself, you have to be really careful to not install it inside of that notch, because if you do, it'll shear off the end of it, and you're going to have to get a new probe because it will not work anymore. As we go back down the crankshaft throw, you're going to be able to see some like scuff marks from past students doing just that and scarring up the crankshaft throw. It's really important to get the proper spacing when you're installing the transducer. It's going to be a space about 1 millimeter away from the crankshaft throw, or 4/100ths of an inch. If it's not within that tolerance, the reading isn't going to be clear. It's also really important not to get it inside of that notch, or else the transducer will break. Here you can see the end of the crankshaft throw. When you're taking out the sidewall plug, as you can see, we are having some issues. You're either going to need like a thin-walled socket to fit around it, or we just wound up using a wrench to either like 16 or 17 millimeters, and we were able to get it off. But a thin-walled ratchet would be best, or obviously a wrench. Throughout this entire procedure, we are constantly referencing CIS to make sure that we are going through the proper procedures, and we may have all the proper equipment and we're falling under the right specifications for everything to make sure that we don't damage any of the equipment like the transducer or the engine itself, because we don't want to be doing something small like this and wind up breaking something far worse. Metal stuck in the oil pan that gets up to the cylinders, yada yada yada. It's not something we're trying to do, so we're playing everything by the books, trying to stay safe and get everything done properly. This is when Dan and I actually started to get the timing probe installed. We started by changing the adapter for the C13 block and getting the O-ring installed on that as well. This was to make sure that we weren't spilling oil outside the engine and we were properly installed it. We also wanted to make sure that we were 75 degrees past TDC. That's what CIS calls for installing it, as well as facing it about 1 millimeter away from the crankshaft throw, or 4/100ths of an inch. We're also making sure that we're not inside of that specific gap that I pointed out earlier. That's where you can shear off the end of the transducer, damaging it and destroying it. So what we're looking at right now is some marks some previous students have made on the bell housing and flywheel of the engine. There's a mark for the 75 degrees that CIS calls for after TDC that the engine should be at before you insert the timing probe. However, this isn't proper procedure. This is just something that we were able to do. We did go back and make sure that we were at the proper 75 degrees past TDC that we needed to be in. This next table is the table that we used to find the number of degrees past TDC that we need it to be in. This table is the same, or it's used for the same engines from the C7 to the C18. The one we're looking for is the C13, which is right in the middle, which calls for 75 degrees in normal rotation, that being clockwise from the front and counterclockwise from the rear. The table after that is the location of the calibration port, which is the hole that you can see the crankshaft counter throws. And it tells us that we're looking for the number 8 throw. This next section is the procedure to installing the transducer into the engine. What is required to do if you don't have a specific plug is you need to tap into the ECM itself on the specific pin. Fortunately for us, we have a plug already installed. There you can see the transducer that's plugged into the side of the block, and there you can see that where we have tapped into the harness for the plug itself. The end of that plug is what connects into the transducer, and then the other half is what is plugging into the ECM. The rest of this sys page is the procedure leading up to calibrating the timing, checking for diagnostic codes, making sure everything is all right. We're going to want to get the engine warmed up to operating temperature. From there, we can get the engine going at about 1100 RPM plus or minus 50. As you can see that on sys itself. Once it is within those two areas, you can go ahead and start the actual calibration. This is when we started to get the engine up to operating temperature. Unfortunately, I filmed the other half of this upside down. This is just the engine running. We let it run for about 10 minutes before getting the actual calibration underway. Just letting the oil and the coolant get up to temperature and make sure that we were all within normal specifications. This is how we had our exhaust being sucked out, just hooked up to the normal exhaust system. And this final clip is the actual calibration. It only takes about 15 seconds and not much more to that. Just hit start and continue, and calibration is successful. And that's it. Thanks for watching.